Myself, Narayan Reddy. I am from Math YouTube channel. Today, in this class, I am explaining about logarithms. What is meant by logarithm? Very important this one. Please see, observe here. Log is nothing but accessing. Logging, login, log out. Accessing, log out, outcoming. Okay? So, what is logarithm? Rhythm is nothing but a procedure. That is order, is maintaining order. So, logarithm definition is nothing but you can access the values in a certain order. We can access the values in a certain order. Is called logarithm. Okay? This is the definition of logarithm. But the different types of logarithms are there. Types. For example, different types. Number 1, natural. Number 2, common. Number 3, binary. So, what is meant by natural logarithm? What is meant by common logarithm? And what is meant by binary logarithm? So, which is also called as Napier's logarithm, which is common log, which is binary log. Okay? So these are 3 different types of logarithms. But in this case, we can use the base as E. Base as E. In this case, we can use the base as 10. In this case, we can use the base as 2. That is the difference between these 3 logarithms. This difference must be observed carefully. Not all are not same. There is a difference. That is, whenever base E is there, that is different value. Whenever base 10 is there, that is different value. Whenever base 2 is there, that is different value. Okay? So this difference, this values we have to observe. Okay? These are 3 different types of logarithms. Okay? Now, what is the value of E? What is the whenever base is E? What is the value of log when base is 10? When base is 2? We have to observe. Okay. Now, I will give some example for this. For example, for any positive integer, for any positive real number other than 1, if a to the power of x or a to the power of n equals to x, some x value. So, which consists of, it can be written as, for any positive real number other than 1, if a to the power of m is equal to x, then it can be written as m equals to, this is exponent equals to log a x. log x to the base a, which can be read as log x to the base a, log x to the base a. So m equals to log x to the base a is nothing but a to the power of m equals to x. We can be written as this one is in the form. That is important. Exponent is here, base is here, to the base a to the power of m. This is base, this is exponent. S base is same, base x value. That's all. Here you observe one important point is a to the power of m equals to x. Here base is a, exponent is x. So base is here, base equals to a, exponent equals to m. So here also m equals to, this is exponent, equals to log x to the base a, base same, base is same. So log x to the base a means this is log x value, value of x to the base a. So in this point you have to remember. Here base is same, value, exponent is this one. That's all. Exponent equals to this one. So a to the power of m equals to x. This way you have to remember this point. For example, I will tell one thing. A to the power of some example, take example 10 cube equals 1000. You know that. How do you can written in logarithm? What is base now? Here base is equals to 10, exponent 3, value 1000. Okay, now base is means log base 10. What is the value? 1000 equals to exponent 3. That means 10 cube equals to 1000. Okay, 10 cube equals to, so in this way we have to write this one. Observe here, this is base 10, is base, exponent, value, that's all. So this is an important point. You can take some more examples regarding this. Okay. See the next example. For example, 2 to the power of minus 3 equals to 1 by 8. This can be written in logarithm as base is 2, log base 2, 1 by 8 equals to exponent. That's all. Same manner, 0.1 whole square equals to 0.01. This implies log, what is base now? 0.1. What is the value? 0.1. What is the exponent? Square. That's all. Okay. So in this way you can write in logarithm form. Now another important point is characteristic Monte. Whenever you can see the logarithm, two parts can be obtained. What is that one? In logarithm, two parts can be obtained. What are those? Number one is characteristic. Number two is Mantissa. Very, very important point, this one. What is characteristic? What is Mantissa? Is nothing but integral part of the logarithm, integral part of logarithm. That's all, simple. This one is decimal part of logarithm. That's all. Integral part, decimal part. Example, log 20 to the base 10. Log 20 to the base 10. This is common logarithm. Equals to what is 1.3010. Here characteristic value equals to 1. Mantissa equals to 10. So this is characteristic value, this is Mantissa value. That's all. Okay. Now see some values regarding this one. For example, .001 log. Here, how many digits are there after decimal? 1, 2, 3. That is bar 3. So .003 means bar 3. 2 zeros, 3. So 10 0 nothing but 10. So what is characteristic value here? Characteristic value equals to bar 3 or minus 3. Okay, and Mantissa equals to 0 0 0. That's all. So this is characteristic and this is Mantissa, which you have to remember. Okay, some differences are there between these three types of logarithms. X value, log x to the base 10, log x to the base 2, log x to the base e. This is common logarithm, binary. This is. Now see dear friends, here x is the value and this is common logarithm, binary. This is natural logarithm or Napier's logarithm. Okay, this is binary logarithm BL, this is natural logarithm NL, this is common logarithm CL. Remember this. Okay, so log x to the base 10, that is common logarithm. Whenever 0 is there, that is undefined. Whenever 0 plus is there, that is also infinite. Okay, 0.1 or 0.1. So what is the value of whenever the common logarithm? Bar 1, 0 0. 3, bar 3, 3 2 1 9. So that is the difference between these three logarithms. So which you have to observe. This is common logarithm, this is binary, this is natural logarithm. These are different values between among these three logarithms. Okay, this different you have to observe. This is most important because you have to observe base. What is the base is there? Regarding that, according to that, we can do the problem. That's all. We don't use always only one values. Whenever you see logarithm table, we have to observe what is the base. See, this is natural logarithm or binary or common logarithm. That point you have to remember. Otherwise, there is a problem. So, these three differences which you have to observe. See some properties of logarithms. Properties. Number 1, log of log m to the base a plus log n to the base a. That means mn means m plus n. But remember, mn equals to m plus n. That's all. Okay. Number 2, log m by n to the base a equals to log m minus log n base a. Okay. So m by n equals to m minus n. Okay. Again, log a to the power of m equals to m log a. M log a. So this exponent comes to here and this same as. Next one is log a to the power of x equals to log x by log a. Base is some base b, same base, log x by log a. Okay. Next one is log x to the base x equals to 1. Log x to the base x is equal to 1. When these two are equal, that is equals to 1. Next one is 6(1). Log 1 to the base a equals to 0. Log 1 to the base a equals to 0. Now, whenever there is a base, that is 2 or 10 or e, those are called common and binary or natural logarithm. But whenever base is not given, at that time we can take optionally as base 10. Whenever base is not given, at that time we can take base as 10. That is most important which you have to observe. Okay, so optionally you can take as 10, that is common logarithm. Whenever specified natural logarithm, but it's e or binary 2, so those are not given, you can take simply as base 10. That is about a simple introduction about logarithm. Okay, dear friends, thanks for watching Matthew YouTube channel. If you like this video, please subscribe our YouTube channel Matthew and hit on bell icons to get more information. Thank you.